Bob here, Chopper Bob Customs, and we're moving on to the next phase of the JD Garage's CNC plasma table, and that's getting your ideas into steel. So I've been testing this, getting things set up. Now, JD highly recommends Fusion 360, and I can understand why. It's a very good program. It does your CAD and your CAM all in one place. It is probably affordable, but it's more than I want to spend. And there are ways to get it for free, but in reviewing the options, I didn't necessarily feel good about it. So I looked for an alternative. Let's be honest about this. Chopper Bob Customs is a small business, and I have to be able to justify cost, but at the same time, I will be using this to sell services to my customer to cut their steel for them. So, with that being said, I decided to look for an alternative for it, and what I did do was I went with a product called FreeCAD, and here again, as the name implies, it is free. Let's see if I can get it to load up. It has its quirks, and I had to. It had been a long time since I had actually done CAD work, computer-aided drafting, and it took me just a little bit of time to get accustomed to doing it again, and then also doing it in FreeCAD. But basically, let's see if I can pull it up. Yeah, I don't have the actual file on here, but basically what I've done is I've made 3 drawings. One to run as primarily a test because it's relatively simple. The mounting pad for the Turbo 400 for the altered, and then some windshield frames for a project that I'm going to be showing here shortly on there. But at any rate, you make your drawing in FreeCAD, and then you save it as a .svg file, and then you go out to the internet and you open up OpenBuild's CAM program, and you can import the drawings. And I don't know whether you can see them on there or not, but basically what I've done is I've imported 3 drawings onto here. These big ones are the windshield frame parts that I'm going to be doing, and then down in here is the transmission mount. And basically what OpenBuild's CAM program, computer-aided manufacturing, does is it converts it into a G code that the machine can understand. And then from here, you put it into OpenBuild's control. And here's what the G code looks like for part of it anyway, for the transmission mount that I'm doing. Right here is all the G code, and here it shows, if I can get it to come up quick. Yeah. There it shows the tool path and the part being cut out that is run. And so once you get it to this point, basically all you have to do is push the run job, and if you have everything taken care of, it will run. Now, the JD's Garages puts out a Z code or Z axis check piece. It's basically a square with a circle cut out of the center of it, and that they use that to test to make sure that your machine is all set up correctly, and that worked very well. I had some struggles getting the FreeCAD OpenCam open builds cam and open builds control to translate into what was actually going to happen on the machine. Did contact JD's garage, talked to him a little bit. He set me on the path where I misunderstood some of the instructions, got that sorted out, and the machine ran great with that. I still had some difficulties getting this to work, but I did manage to get things to go with it. And let me move the camera over here and get it down to where you can see it, and then I'll start running the program and you'll see how the machine operates. Okay, so I'm going to go ahead and push the button. Now this is what I had the biggest problem with, was the touch off, where the tool will go down, touch the surface, and then back off the correct distance for the cut. Now these are 4 inside cuts on 2 slots that are rounded end for bolts, and 2 slots that are basically rectangles for welding tabs for the mount to the cross member on the car. And now we're going to go ahead and make the outside cut for the actual part. And of course, when I get the actual plasma unit turned on, we'll actually cut the part. But for now, we just need to know that the machine, this machine, the CNC plasma table, is working correctly. And then we'll make sure that the controls and the plasma unit works correctly. I'm going to give you an idea of what the deal is with the with that Z offset. What happens is the program tells the torch head to go down, Z-axis negative, until it touches the work surface. There's a little micro switch that clicks, and then it brings it back up to the correct cutting height. So let me run through this. Yeah, this will work. To show you that if I'm running thicker material, now I've gone up 1/4 inch in thickness. And I don't know whether you can see that or not, but basically the torch head is the same distance away from the material as it was when I was cutting the thinner material. So, and now I'm 1/4 inch thicker. So it does... that's one of the reasons why I wanted the Z-axis. You can build this without the Z-axis control. A couple things about that is you have to set up the torch height every time manually. And then also, if you have any discrepancy on a macro scale, like if the side over here is different thickness or different waviness than over here, you have to set it up for over there for that cut. Whereas this, you can cut through the whole sheet and it will pretty much hit an average on the actual height. Now, one of the things that JD's Garage does build and sell is a THC, torch height controller. And what it does is it uses feedback from the plasma machine itself. It basically tells how much voltage is being used to maintain the amperage, and that goes back into basically a small computer that says, well, you're too close or too far away from the cutting surface, and it will actually adjust the Z-axis real time during the cut, so to give you a better cut. And if I get all the bugs worked out of this, someday I may want to go with that THC. But for right now, I did want it so that I didn't have to set the machine up every time, and that I was able to make sure that if there was any unevenness in the material I was cutting, that I wouldn't have to stop and set the machine back up for a different area of the piece of material. One thing, if you're cutting thin material that tends to warp, doing a lot of cutting on it where it might bow up, that's where the THC really comes in handy, in that it's going to be constantly monitoring how far away the torch head is away and adjusting it. With that being said, the next step on this will be to actually put water in the water pan and fire the plasma up and make the cuts, and that'll come up next. The other thing that I did want to say about this was that I'm really pleased with the way it works. One thing about it though, the Fusion 360 with the CAM program in it, it spits out the information you need right away to make this Z-axis work correctly. I had to fiddle around with it on the Open Builds CAM using the FreeCAD. It takes some work, and you've got some things that have to be done. If you're interested in what I had to do, I'll have to go back and actually think about what I did to try and make a video. So I'm not going to do that in this video. If you're really interested in it, leave a comment. Otherwise, when I come back, we'll have water in the table and turn it on and start cutting. Okay, so I've got the water pan filled with water up to about 1/4 inch away from the work surface. I've got my ground clamp on good and solid. Got everything squared up on the table. I'm fairly certain I have all my settings correct on the plasma and the machine. I basically have, I tried very carefully to get the 1.5 millimeter cut distance, 1.2 millimeter pierce distance, 1.5 second pierce delay. I've got the speed set at 2,000 millimeters per minute, which is just a tick under what the Lotus manual says to run it at. I've got the machine set at 40 amps and 55 PSA. Here again, this is what the Lotus cutting reference is, and for mild steel. And for 10 gauge, what I've got in here is 1/8 inch, so it's actually 11 gauge, so I'm a little bit hot, a little bit slow. I've got the G code created, and I've got it loaded up in controls. And all I have to do now is push the run job arrow, and we'll either have the magic happen or it'll all go to doo-doo. So I guess there's no time like the present. Here we go. Okay, let me go fish the part out. Well, let's go over and see what it looks like. Okay, so there we go. Let's see if I can fish it out of there and see how it looks. Okay, so the slag indicates that I might have been just a little bit slow, but on the whole, for a first piece, let's see what happens. They say if you drop it on the ground, a good portion of the slag might come off. Not too shabby. I am happy with that as a first piece. Okay, so with that, I am on my way to doing plasma cutting with the JD's Garage's
Okay,
plasma.
so my intention was to shoot this video and have everything go perfect right from the beginning, and it didn't work out that way. So I'm gonna have to edit it, and so this is gonna be choppy, and I'm probably gonna repeat myself. But I apologize. But I'm trying to get this as accurate as I possibly can for the final. Well, it isn't going to be the final episode, but this is sort of the final episode of JD's Garage's CNC plasma table. Fingers crossed. Anyway, so let me run real quick what I had to do here to make this work. So I'm using FreeCAD, and of course, you know, JD recommends that you use the Fusion 360, which if you can, that's great. I would go ahead and use it. It's just that I've done the cost justification on it, and at my present state of business, I just cannot justify it. I don't want to lie to them and tell them that I'm not using it for commercial purposes. You can do what you feel. It's definitely going to be better if you can use Fusion 360. So what I'm using is I'm using FreeCAD, and then the Open Builds cam won't accept the DXF that FreeCAD puts out, and so I have to put it out in an SVG file, which then does not have the correct scaling when it comes across. And so I have to change the scaling. In Open Builds cam, you can only change it in one direction, so it's slightly off in the other direction, but for what I'm doing is close enough. If yours has got to be perfect, this isn't going to work for you. And then you put it into Open Builds Control, and then you cut it. And the other thing about this that I've had to fool around with is I've got this set up with the Z-axis touch-off. What that means is that the torch head goes down. When it touches, it hits a micro switch, and then it knows how much to back it off. And I've had to fool around with how much play there is in the micro switch and adjust it by changing in Open Builds cam the pull off. So to get 1.5 millimeters pull off, I've got it set at 3 millimeters pull off. Okay, yours is going to be different if you try and do it this way. What you have to do is you have to run the program with the plasma machine off, stop it, and take your feeler gauges and see if you're 1.5 millimeters off the surface. Now, once you have it set and you know where your machine likes to be, unless it gets out of adjustment, you should be able to use those numbers on any subsequent thing, because at that point, the head comes down, touches the material, and backs off the correct amount to give you the 1.5 millimeters. Anyway, actually what I'm doing is I'm backing off 1.2 to pierce it, and then once it pierces, it backs the head up another 0.3 millimeter. So with that said, what I have done is this was the first piece that I cut, and I showed you what it looks like. I still haven't cleaned this up because I can't use it because it turned out to be undersized. Okay, so then what I did was I went in and tried to make adjustments on it to get the part in the right size. And I am very, very close with this one right here. I'm very happy with this one. I'm pretty sure I can use it. The slots are just a little bit small. Probably if I had it to do over again, I would probably open the drawing up a little bit. But the bolt holes are going to work fine, and when it cleans up, it'll be just great. But here you can see the difference, I think, in size. And I took care of changing that in OpenBuild's CAM, because what you can do is you can go into it and change it. If you try to do this and you can't figure it out, leave me a note in the comments and I'll shoot a video on how to do it. But because I don't recommend doing it this way, you know, if you want to try it, give it a try. And if you need some help, drop me a line in the comments and I'll be glad to make a video on it. But now what I'm going to be doing is I'm going to be cutting out a windshield frame for the rat rod project that I actually haven't shot any video on yet. And I did cut out a frame for it, and it was close, but my drafting was off, because basically I am taking a car, actually a truck cab, that somebody chopped horribly. I mean, I said the other day to a guy, he said, yeah, it really looks bad. I says, the longer you look at it, the worse it looks. And so I've gone through and I think I've solved the correct dimensions for this. Actually, I'm going to have to cut a different one for the left side than the right side, because the chop is that bad. It's horrible. So I've got everything all set up, and I've gone ahead, made my adjustments on OpenBuild's CAM. I've got it loaded up in OpenBuild's control. I've talked to JD's Garages. The Lotos says you can run it at 2,200 millimeters per minute. I had set the machine at 22,000 millimeters per minute. And when I made the cut on this piece right here, it didn't stop cutting, but it wasn't good enough that it blew the material out. And so I talked to JD's, and he runs his at like 1,100 millimeters a minute, which is considered almost half of what I was running it at. And so I'm going to try this one at 1,100. He also runs a little bit more air pressure than I was running. I think I had it set at 60, and he has his at 65 when he's doing 1/8 inch. And he also does not, I was running at 40 amps, and he runs at 38 on 1/8 inch thick. So I've backed it down to 38. So this is 1,100 millimeters per minute, 38 amps, 65 PSI pressure, and it's been hopefully scaled correctly. And I'm going to go ahead and give it a cut. And so I will probably, probably what I'll do is I'll probably cut this real time on the camera. And then when it comes time to edit it, if it seems like it's going to take too long to get through on the video, probably what I'll do is I'll probably show you some real time and then speed a big chunk of it up and then go back to real time at the very end, and probably post how many total minutes it took to shoot the whole thing. So with that, I'm going to go ahead and hit run program, and hopefully this is going to work.
Okay. That worked really, really good. The only thing is, I may have had the machine set wrong because it started the holes on the outside rather than the inside. So I'm going to have to figure out what I did wrong there. But that's going to be for plug welds, so it doesn't really matter if there's a little bit of a whoop-de-doo on the end of it there. And yeah, let's see what happens when I drop it. I knocked a bunch of the slag off when I did that. It's going to take minimal cleanup to get this thing ready to use. Now, in the rat rod video, I will show what whether or not this was a successful cut or not. But right now, I am happy with the way that looks for the left windshield outer frame. If I don't say it elsewhere in this video, please hit the subscribe button, hit the notification bell, be looking for the rat rod video, and like the video. If you got any comments, like I said, if you want to know how to set this up, leave me a note on that. Beyond that, I think I'll go ahead and use my normal chopper bob out, and we'll go from there.